Alright, now we're rolling. Now we need to start talking about, very quick, well, not very quickly, function notation. We have done a lot of function notation already, so I shouldn't have to go over too much of that because we've been through a lot of it. Okay? If I'm given a relation, y is equal to 2x, now from that I should see that that's not just a relation, that's also what we call a function because it's the equation of a line. The y values are determined from the x values, so that we say y is a function of x, which is abbreviated to y is equal to the f of x. So function notation, in function notation, all I'm saying is that f of x is equal to y. Or I read that the function of x, which is y. Okay? Because we said earlier that x is the independent variable and y is the dependent variable, all right? What this is saying is that my function of x is equal to y. Okay? So you'd read that the function of x is equal to y. Okay? That's f of x. We also pronounce that f of x. So we say like f of x is equal to y. All right? Now, what that means and what function notation can do for me, though, if I have this general rule is equal to 2x, if I'm given a value of x, say when x is equal to 1, I don't have to write all of this out. I can just abbreviate that if I know what my rule is, and I can say f of 1 is equal to, and then I plug in 1 wherever x would be, and I say that. So what this says is that f of 1 is equal to 2. Or, what it's really saying is that when x is equal to 1, y is equal to 2. Right? That's function notation. Right? Similarly, if I say in this rule, if I say f of 2 is equal to 2, and then again I put that 2 wherever the x's are, and I come up with f of 2 is equal to 4. Right? And I can put any value in there. I've not been given a restriction on my domain and range, as it were, in my function notation. I've just been told that this is a rule, and I can be asked what is y when x is something. And this is how I figure that out. Okay? And this is the correct way to write that out. All right. So let's say for any given function y is equal to f of x, the value of y when x is 0 is written, and that's what we just talked about. Okay? So the value of y when x is 1. That's function notation. This is function notation right here. All right? So for worked example, I'm doing worked example number 9, and I've got the rule here is the function is equal to x squared minus 3. Okay? Now, they're asking me to find what's f of 1. So all I do is for f of 1, I've got the rule here. I just plug in 1 wherever I see an x. That's 1 squared minus 3 is equal to 1 squared is 1, so 1 minus 3, and then that's equal to 2. Okay? Same rule, different value. If x is equal to negative 2, what's y going to be able to? So f of negative 2 is equal to, and again I just plug that in. So I've got negative 2, I want to square that, minus 3. See, negative 2 squared is 4, because a negative times a negative is a positive. 4 minus 3, and then I get 4 minus 3 is equal to 1. Okay? Now I could keep going and I can plug in any value at all. But the basic rule of thumb is all I got to do is whatever they put in these brackets here, if they want me to find the f of whatever, I just plug that in wherever the x goes. And it's as easy as that. Okay? All right. now you need to go into, and I guess special types of functions, we've talked about one-to-one, we've also talked about that. I guess we need to talk about hybrids, and with that, you definitely need to know this. A hybrid function, you have clearly defined domains and ranges. So I'm given a function, f of x, in your book, and I've got two rules for this one function. Okay, I've got x plus 1 and I've got x squared, and then I'm given a range, 4, and then my range is x is less than or equal to 0, and then for the second part I'm given 4, x is greater than 0. So all this is saying is that I've got a function that has actually got two parts. It's a hybrid because it's put together, it's kind of taped together, if you will. And I've got two rules in this one function. I've got x plus 1 and I've got x squared. And then I've got two different ranges. Okay? So if I were to graph this, I would say, well, this is a line. Okay? So for x is less than or equal to 0, anything to the left of that, this is 0, the origin, and this is x0 and y0. Anything to the left of this, I'm going to use this rule, x plus 1. Okay? And that would be a line that would have a slope of 1, and it would intersect the y-axis at 1, so it would be something that looked a little bit like this. Okay? And I'd go up to and including that point, x is less than or equal to 0, and I'd go up to 1, so this would be 1. Now, though, I'm given another rule, and I've said, well, for x anything greater than, I'm going to go x squared. So I'm going to jump over here, and I'd have to start plugging in values such as 1, 2, 3. And I would find that I'd have to jump over here and start at 1, and then I would have something that looked like that. Okay? Because for this second one at least, I'd make a chart up, and I'd start at x and y, and I would say 1. When x is 1, then y is going to be 1. That's where I got this point right here. And then when, let's say 2, when x is 2, y is going to be 4 because x squared, or 2 squared, is 4. So I'm going to start curving up pretty quickly, and you'd see that. I'm going to have a curve up like that. All right. That, I just add one more, so I'd have something that looked like this. Okay? All right. So that is hybrid functions. You just need to recognize these different rules and then the different ranges. All right, this is video 2 ending, and I'll have a look at now function notation and special types of functions, and we'll have to do some inverse relations next week. Okay?